Okay, I'd like to give an application of using the quadratic formula, and I'm going to go ahead and use gravity since it's a well-known quadratic in form. And so let me point out that I'm neglecting air resistance in particular. So if you drop something or you throw something up and it comes back down, generally without air resistance, then we're going to say that the motion of that object can be very well estimated by this equation right here. Y is equal to -1/2 gt squared plus v naught in the y direction times time plus y naught. And I keep saying naught, sometimes people say 0, but those quantities mean initial things. So let me break down this equation. You can see that it's quadratic in time. You got a t squared and then a t and then a constant term at the end. Gravity is denoted by this small g, and that is the magnitude of the gravitational constant near the surface of the Earth, which is about 9.8 meters per second squared, or 32 feet per second squared if you're working with feet. This part, the initial velocity in the vertical direction or in the y direction, which we usually denote as vertical, is given in meters per second or feet per second. And again, that just depends on if you're going with meters or you're going with feet for the ultimate height that you're trying to take a look at. And the t is time in seconds. The end term over here, y naught or y0, is the initial height of whatever this object is. Okay, so if you drop something off a building, that initial height is the building height, but it wouldn't have any initial velocity because you're just dropping it. Now, in this case, I'm asking a question related to the season currently. How long will it take for a football to hit the ground after a punt if y naught equals 6 feet and the initial velocity in the y direction is equal to 100 feet per second? So what this means is the kicker's foot is about 6 feet when the ball leaves it, and it's going 100 feet per second only in the vertical direction. It's actually going a little faster than that overall, but in the vertical direction it's going 100 feet per second. So let me answer that question using the quadratic formula and this quadratic equation, although I'm going to need a little space, so I'm going to erase all this here that's describing. That's funny, I said erase. It's not like this is a big pencil that I'm using. Well, same idea. I'm going to wipe all this here. Of course, this does fit the definition of erase, doesn't it? That definition gets pretty broad, like Arnold Schwarzenegger in Eraser. Okay. I didn't pay him for that. He's probably going to call me, say I owe him some money. All right. Well, he's a pretty nice guy. Maybe he'll let it go because I'm teaching math. And right now he's saying, how do you know I'm a pretty nice guy? I've never met you. Well then, I suppose I'll extend that invitation to Arnold then. If you feel like commenting on one of my videos and you like math, then let me know. Okay, so let's now use this equation to answer that question. And I guess I should ask, what is the ground? What is the height of the ground? Now, you might say that's obvious. You might scratch your head for a second and say, oh, well, isn't it nothing? The height of the ground is 0, and the answer to that is yes. So if I'm trying to answer this question, I can set y equal to 0. The height of the ground is 0. Now I'm going to fill in the rest of the information. There's my 0 equal to -1/2, and the initial height is given in feet, the initial velocity in feet per second, so I'm going to use gravity as 32 feet per second squared. Okay, times my time squared. That's the thing I don't know, the time. I'm trying to find that out. Plus 100 t plus 6 for my initial height. Let me simplify this just a little bit. -1/2 times 32 gives me -16 t squared plus 100t plus 6. and all of that's still equal to 0. And it looks like there is a constant factor in all these numbers. So let me reduce these numbers. It'll make my life easier no matter where I go from here. So I'm going to divide everything by 2, it looks like, is the most I can get away with. Okay. And the left side of the equation as well. 0 divided by 2 is 0, equals -8 t squared plus 50t plus 3 over here. Okay. That looks like all I can reduce. I would ask myself normally, if solving these equations, can I factor it? So I take about 10 seconds to see if I can factor it. And if I don't see it in 10 seconds, regardless of whether I can factor it, I'm going to proceed to use the quadratic formula. And it's not obvious that it factors. In fact, I don't think it does. So I'm going to go ahead and use the quadratic formula. And instead of x, we're working with t, but that's OK. We can still match it up to the standard form quadratic equation. We can say that a is equal to this guy here, -8. B is equal to 50. And C is equal to 3. And plug it into the quadratic formula. Now I'm going to need a little bit more space here, so I'm going to erase this. And you can go back if you want to remember the question and the initial information, which is very important. And let's see what we come up with here in the end. Okay, so putting it into the formula looks like the following. Go straight to the conclusion, or the solution, I should say. T is equal to -b, -50, plus or minus the root of b squared minus 4ac all over 2a. And once you plug it in from here, you just got to be very careful as you're simplifying not to drop signs or make silly mistakes that ruin your answer. So let me continue. Under the root, 50 squared. Let's put a 25 and tack a couple zeros onto that. 2,500. -4 times -8 times 3. So that's going to give me a positive overall 96. And continue that. Root bar. And then under all this, 2 times -8 is -16. And I'll just keep going. Try to conserve a little space here. So that's -50 plus or minus the root of 2,596 all over -16. And I think at this point, I'm going to go ahead and separate this into 2 different values. Okay, the top one is -50 plus the root of 2,596 all over -16. And the bottom one, -50 minus the root of 2,596 all over -16. And let's get the approximate values for these things. Feel free to pause it and punch it up on your calculator, see what you get. I've already calculated this out. And what I got for the top one was -0.059 to the thousandths place. And on the bottom, I got 6.309 to the thousandths place. And at this point, I'm going to ask myself, what was I looking for in the first place, in the beginning? And I can see from this equation here, I was looking for a time. So the first thing, a negative time. Well, we're not there yet in history, so this doesn't make sense. And we call this the extraneous solution, which just means extra. It is mathematically correct, but physically incorrect. It doesn't quite make sense for the problem. But this one, the positive time, that makes sense, and time is in seconds, so 6.309 seconds is when this ball is going to hit the ground. Okay, there are more applications to come, and I'm not quite sure when I'll get to that, but have fun with these on your own in the meantime. See you next time.